On the, actually, before we get going too far, these are design guides. Make sure you guys take one before you head out, and we'll go forward from there. So, can you do me a favor? Can you give this to Kelly when she teaches next week or whenever it is that you see her? And then give her one of these. It's just printed out of what's on there. Then she can have it. And then if you guys could just take these and pass them around, make sure everyone gets one. Okay. Okay, so I'm going to show you what the components look like generally and how it's put together, and so that you can kind of see what it is that we're talking about. And then since you're all much greater at drawing than I am, I'm going to ask for a couple of volunteers, and we're actually going to design some systems out on the board and go through the calculations and see what we can come up with. So on this sheet that's going around, it has the Techline CV Quick Install Guide, okay? And the one thing that we always need, did everyone get one of these? The one thing that we have is we have a valve, filter, and pressure regulator for the drip. So the valve is the automatic part that the controller turns on, okay? Standard valve. It could be whose ever valve that you like. Most people, when we're dealing with cities, they have kind of a standardization. They standardize on a certain manufacturer and a certain style of valve, and just from a standardization standpoint, so that they don't have a whole bunch of different parts and pieces. So when you're designing, you'll find out they'll let you know what valves that they like. But after that, they're not so concerned about the filters and pressure regulator. And it's ironic because I'm not as concerned about the valve, and I'm more concerned about the filter and the pressure regulator downstream. So from my standpoint, it helps out quite a bit. So on this header, remember that I showed you the two layouts. There was the light layout, and then there was the grid layout. On either one of those, you're going to have one of these. This is what's going to turn it on. So you're going to have your valve, and then you're going to have a filter and a pressure regulator, okay? The filter, remember when I was talking to you about different drip manufacturers have different filter requirements. Some want more filtration, some want less filtration. That's this piece right here, okay? So when you're doing your design criteria and whatever drip manufacturer you choose, you need to make sure that you look at what level of filtration that they require, and then you need to make sure that the filter is a minimum of that. So as an example, this filter right here, and there's two different classifications on filters. There's mesh and micron, okay? Most people go with mesh, and mesh is the level of filtration that it provides. On mesh, the larger the number, the more filtration, the more stuff it's going to pull out of the water. The smaller the number, the less it's going to pull out of the water. Micron is just the opposite. Micron tends to be more of an international type of designation. So when you're run across some filters that are made overseas, they tend to look at microns as opposed to mesh. It's the exact same thing, it's the exact same measurements. One thing to know is that like on all of our products, we require 120 mesh filtration, okay? This filter here is 140, so that means that it's better than 120. It's filtering out more stuff than what the drip needs. You got to be really careful. I typically specify exactly what it is that they need. If it's 120, I will specify 120. If they need 200, I will specify 200 and nothing more, because if it requires 120 and you put like a 200, that means that it's a 30% increased filtration, it's pulling more stuff out of it. That means that you have to clean this filter a lot more frequently. Okay, does that make sense? So when you're specifying that, that's what you're going to look at. The pressure regulators, typically when you're designing with inline drip tubing, it doesn't matter whose it is, always specify the highest pressure one that you can get. And they typically are right around 45 to 50 psi. When you're designing these little point source guys that you punch a hole in and you punch them in, you're going to want to be around 25 to 30 psi max. And the reason for that is that we go with lower pressures is the more pressure we put on them, the more likely that they are to get blown out by the increased pressure. So that's why they tend to be a little bit more maintenance. These also require typically more filtration than this. Okay? So we're going to have a valve, filter, and a pressure regulator. And a lot of manufacturers have put them in kits like this anymore to where the contractor doesn't have to assemble them. And when you take a look in the catalogs, you're going to be looking at the level of filtration that's required for that, and then you're also going to be looking at the flow range that is set up for these. So this one here, I know that the flow range on this one here is 0.2 to 4.4 gallons a minute. So if we have a zone that's putting out 8 or 9 gallons a minute, we know that this is too small. Okay? Then we would go to a different one. And primarily for this, it's the pressure regulator that makes that difference. So when you're specifying your control zone kits, look at the valve that's preferred. If there's not a preferred valve, then go with your preference. And then look at your level of filtration that's required for your drip, and then look at your pressure requirement that's required for your drip also. Okay? So we're going to connect into this. On that sheet, you can see that it'll show that. This is that control zone kit. Then if we're going to a grid layout where we're going to be connecting into PVC, okay, and we'll go through some examples on how that works, but basically is what you're going to have is we're going to have that grid of PVC header that's going to be going across the top. And as what we're going to do is every 12 or 18 inches in that grid, we're going to be cutting that PVC and putting in a PVC T. And then we're going to be screwing in this is a MEL adapter that goes into there that's going to allow us to transition from this header to the drip tubing. So the drip tubing will connect right into this fitting. Okay. On the inline tubing, when you use brown fittings, and the manufacturers of inline tubing make their own fittings so that when they put the tubing on them, that you don't need to clamp them. Okay, so there's no clamping. And so when you use brown fittings and brown tubing, there's no clamping. If you use gray fittings, which are manufactured they're just general fittings, then you have to clamp them. So always use the manufacturer's fittings with their tubing, okay? And then you don't have to worry about clamping them, which adds costs and labor, okay? So you'll have these set up like every 12 or 18 inches in that PVC in that header going along. Then we're going to connect our tubing, and we're going to go down to the end, and we'll have another one facing the other direction, okay? So those are the parts and the pieces. On that, we see of that manual ball valve at the end that we use to flush. We can use something as small as this that connects right into the tubing, and really all it is a ball valve that's closed, and when you want to flush it, you just open it up while it's running, and it spits the water out, and it gets all the dirt and debris out of it. And obviously you do it while it's running. If you get it, as you get into bigger systems, and let's say you have 1-inch PVC, you might actually use a normal 1-inch ball valve on there instead of a smaller one, just to get the volume of water out there. When you design these flush valves, we show it in a valve box. So always put it in a valve box so that they can find where it's at. And then also it's a good idea to create a sump, a gravel sump in underneath it, so that when you open it up to flush the water out of it, or the dirt out of it, it's going to be putting out quite a bit of water, so that that water goes down into that sump and it doesn't run out over the curb or something like that out into the street or sidewalk. Okay? When we're using, remember that other one where we did the light layout, where we just basically snuck it through the landscape bed, is what you'll do instead of creating a header like this, is you'll run your PVC out to like your shrub bed, and then you'll make this connection in there, and you'll bring this up to the top, and you'll connect your NetFM or your inline tubing to this, and you'll snake it out through your shrub bed and then connect it back into here. This replaces this. So on that light layout, it tends to, remember your application was smaller areas, residential applications, flower beds. This, okay? More commercial, larger shrub beds, we're actually going to create a header and go at that can handle the larger areas, okay? When we're designing, when either one of these, we have that header, it's very important to know what our total flow is for that zone, so that this header can be sized correctly. If we have a zone that we're going to be irrigating, and we're going to have 30 gallons a minute irrigating that drip zone, and this is 3/4 inch pipe, we know that it's too small of a pipe, and it's not, we're not going to be able to irrigate that area effectively. Same with this. When we use this connection, our max flow is 10 gallons a minute. We can have 5 gallons a minute coming out of this connection and 5 gallons a minute coming out of this connection. One thing to note mentally on these is every connection, the maximum flow is 5 gallons a minute on this. So if we have 2, 10 gallons a minute. Okay, so we'll go through this in the design. It'll make a little bit more sense.
Are all those light ones, are those on surface, or can you do subsurface with that as well?
Either one.
Okay.
Yeah. Typically, PVC is not UV resistant. So when we do an on-surface situation, basically is what they'll do is they'll put it below ground and they'll put a slight angle to it and sneak it up so that it lays on and comes up onto the surface and then lays out. And then obviously if it's below surface, then you just keep it flat. Does that make sense? This one here typically is coming up and is on grade.
Yeah, okay.
Okay. Now we can have, if we have shrub beds and we have 3 or 4 different shrub beds and they're all smaller ones, we can run one pipe through all of those shrub beds down below, like a 3/4 inch or something, and then stub up in each shrub bed with one of these and handle it that way. But we'll get into those details here in a few minutes.
You're probably going to get to it, but how is this brown tubing attaching to the brown tubing?
With the T.
What is the T?
It's just one of these brown fitting T's. So as it comes back in on itself, you'll cut the brown tubing and connect them together with a T. Okay?
So you actually slice down the middle of this long one?
No, we just cut it.
Oh, you just cut it and then slip it in?
And then slip it in, put it together,
Okay.
and then we bring the other one and tee it right into it. Does that make sense?
So you're not cutting it completely?
We're cutting it completely in half,
Got it.
and all we're doing is so that we can pull it apart to put the T together.
Okay.
And the question was, I forget who it was, asked the question about repairs. When we plant the tree and we have that grid out there, we turn the system on. Basically, you're going to take a coupling, and what you'll do is that tubing's cut, you'll turn the system on, you'll take this fitting and you'll just put it into that tube. Then you'll put another one on the other side of it, on the other tube, and then you'll measure the tubing and then just connect the two, and that's your repair. It's as simple as that. Okay? And those are really the parts that you need to deal with when we're designing this system out. On that one where we show the T's coming in on that, that's how we handle the curved areas. So we'll just step it down into the other areas, or we'll just have it follow the tubing like we did in that one project. Okay. So let's design a system. Who wants to help us walk through this? I'll do the first one. Okay. So turn your catalogs to page 8. Okay? And the first area that we're going to irrigate is this one right here. And we're going to go with this number first. So it's 300 feet long. So the first thing when we're designing this, the first thing that we want to know is we want to know the square footage of the area that we're going to be irrigating, okay? And we want to know some general dimensions. So we know that this is 300 feet long and it's 10 feet wide. It's going to be shrubs, okay? That's one of the things that we need to know. And our soil's loam, okay? So what do we need to figure out first?
Emitter flow.
Emitter flow rate. Okay, so what emitter flow rate are we going to use?
0.4.
0.4. GPH. Okay. Then what do we need to know?
Emitter spacing.
Emitter spacing. Okay, what's our emitter spacing?